4 to 1. Not enough. Maybe okay. What?
The sun still shines.
You're so complaining. Oh, it's too cold. It's too sunny. It's too hot.
The line is read by the bottom.
Huh?
The sun
Yes.
is like the shine the
Yes.
line, and the line is read by the base.
And in your eye. Yes.
Yes.
Okay.
Exactly.
Now I understand, my students. Right.
Okay, the student says that finally, so.
You feel so good. You feel tired.
Very tired. Very tired. Okay. There's the next lesson. Why is the screen a bit messed up? Okay. Weird. But anyways. Grace! Who are you talking to? Your mother? No. She has a phone? Yes. Pakistan are playing against India soon. World Cup cricket, aren't they?
Oh yeah, they are.
When?
I don't know.
Next week?
Yeah, maybe.
Yeah.
I heard they are saying they were not playing, but they are playing.
They are playing. Okay, yeah.
That will be a superb match.
Yeah.
The rivals.
Last match I watched was Ireland against Pakistan, I think.
Who won?
Ireland, actually. I don't know. I don't know how often that happens, though. I don't expect it happens often.
It was once in the World Cup, Pakistan knocked out by Ireland.
Yeah. Well, like I said, this is the last time. This could have been like 5 years ago.
Yeah, it was.
Yeah. I was only watching it because I was in a takeaway, and the owners must have been from Pakistan, so they had the game on the TV. So I was watching it. Oh, that's good. Okay, yeah. All right, power and efficiency.
From the TV.
Yeah. Well, I think they were from Pakistan. I think so. Anyways, I'm not sure. I mean, they had the game on, so.
Maybe.
Yeah. Okay. So let's see. Yeah. So imagine this. You carry 1 kilogram up a hill, or 1,000 ants carry 1 gram up a hill, one by one. And then at the top of the hill there are 2 piles. Your 1 kilogram, and then the ants 1 kilogram. You see your 1 kilogram, and you see the ants 1 kilogram. Who did more work, you or the ants? What do you think? Ants?
1,000 ants did it.
1,000 ants.
And
Each carried a gram.
Okay.
One people and
I
one
think.
One person and 1,000 ants.
Same?
The same what?
I know that the ants.
So look. So you carry up 1 kilogram, and then the ants carry up 1 gram, 1 gram, 1 gram until they also have 1 kilogram.
The ants did more work.
So the ants did more work.
Because they had to go many times.
Yeah?
The distance is longer.
Yeah, what do you think? Ants or person? Ants, yeah. Yeah. No. No. They both did the same amount of work, because this here has potential energy. Okay, I didn't hear you. The same, because the potential energy here is mgh. And what's the potential energy here? mgh. Now, where did it get this energy from? Well, this one got the energy from the person, and this one got the energy from the ants. So they both did the same work.
But it's just a work done.
Yeah.
Because it's times 1, 0. Yeah, I get it now.
So they both did the same work, but in your mind, you feel like the person has done more work. But there is a difference. Which was quicker? The person was quicker. The person, yeah. The person went one time, but the ants went 1,000 times.
No, but I thought it was 1,000 ants.
Well, it doesn't matter if it was the same ant or 1,000 ants. Yeah. Okay, if you want, it's which do you prefer, 1 ant or 1,000 ants?
1,000 ants.
1,000 ants, one by one at a time.
Okay.
Went up, okay.
But why can't they go up together?
Okay, they go up together. Alright, if they go up together, then clearly it's the same.
Yeah.
Yes. So, the difference here is the time. The man does it quicker. So this gives us the idea of the importance of time. Not only do we need to know the work, we need to know how quickly the work was done. Well, the answer is it's the same. Yeah, so this gives us the idea of power. And power is the change in work per time. So in other words, power is work divided by time. So who had more power, the man or the ant?
Man.
The man, because his time was shorter. He did it quicker, so he has more power. What's the unit here for power?
What?
Yeah, but if you look at the formula,
Joules
joules per second. Which we also call, as you said, a watt. 1 watt is 1 joule per second. Okay, so you need to write all of this down. Known as 1 watt. Oh, so need this coffee. What's early? That's actually the time I'm supposed to finish at.
Are you sure?
Well, if I don't give you a break. I guess you had a little break.
Yeah, so 8.
8's okay. If you're good.
Of course.
If you're bad, 10.
No.
And if you're very bad, 12.
Of course not. If I am bad, they are good.
Oh, I know they're bad.
No.
Yeah.
Of course not.
Okay. You got this? Nearly. You have this though.
Yes.
Yeah.
No.
No.
What about mid-semester? How much notes will be usually?
Mid-semester?
Yeah.
What do you mean?
Like test coming after this.
Oh yeah, it'll be a 1 hour test.
Yeah.
Everything we've learned.
Yep.
Even this, even today.
Everything
Are you
before.
sure?
100% sure. Everything before the test could be on the test. I won't ask you anything after the test. Only the things we've studied before the test will I ask you.
Never tried it.
First time? Now, does it taste better with water? No. You prefer no water.
Because it's sweeter without water.
I know that.
I prefer no this, just water.
So why did you buy it?
Because I want to try.
Oh.
And it's cheap.
Ah.
1 liter, €1.
Ah. This is the real reason.
Yeah.
Yeah. Okay, do you
And
do you
I
have this?
want the juice.
Yes. That's not really juice. That's more like Fanta.
Okay.
Yeah. Yeah.
So good. Look at this. This
Yeah.
bird and this typhoon.
Yeah.
Never buy this.
Never buy this. Okay. Thank you for your advice. Okay. Do you have this?
Yeah.
Yep. All right. So you don't need to write this down, but we just need the idea. When you convert electrical energy into light energy, you have not used any energy. Yeah, you have converted it. So you know this. The electrical energy changes into light energy. But you didn't only get light. Now, if you think about this light here, yeah. See where Amanda is? The electrical energy comes from there, goes into this, and changes into light energy. but it also changes into heat energy. Now, do you want the heat energy?
No.
No, you only really want the light energy. So the heat energy is wasted. You understand? Yeah. So you don't want the heat. In fact, this light here is 100 watts. That means 100 joules per second. So 1 second, 100 joules of electrical energy goes into the light. How much do you think comes out as light, and how much do you think comes out as heat? So 100 joules go in. How much do you think will be light energy?
90 joules.
So you think 90 joules will be light and 10 joules will be heat. What do you think?
Yeah, same like.
You would say the same?
Yeah.
90 joule, 95
95, 5.
light, 5 heat. What do you guys think?
98.
98 what?
98.
Looks like is it 50-50?
98.
50-50 maybe? 98?
9. 2% heat.
Okay. What do you think, Sophie? You think complete opposite? 2%
Yeah.
light, 98% heat, and you agree with her. So the answer is 99 joules heat. Only 1 joule for something like this might be light. So 99% is wasted as heat. Yeah. Now, the light bulb is an extreme example. It's not always like this. So, for example, like a heater. A heater would be 100% heat. Yeah, so it's good. Nearly 100%.
That should mean like if it's 1 joule of light, heat should be more, like it will be much heat.
Oh yes, yeah.
Does that mean light only has 1% efficiency?
All light bulbs do. Yeah, most of the energy is heat. Yeah. Something like your car. Would you know what a car would be? How much is wasted as heat?
I know that it gets very hot.
It does. The car does get very hot. So what do you think?
99%.
It's not. It's not as bad as a light bulb. No.
20%.
More than this. Wait, wasted or wasted? In fact, for a car, I think it's about 60% as heat. Yeah. And only 40% is kinetic energy. Yeah. So this gives us the idea of what's called efficiency. How much energy is wasted? So 99 for light. Efficiency. So efficiency is a percentage, and it's the percentage of useful energy compared to the energy you put in. So as a formula, it's like this. Yep, got that? Now, there is another way to write it. If you divide energy divided by time, what's work divided by time? You had that formula today. Power.
Yeah.
So if you divide these by time, you can change them into powers as well. So if you want, it's energy or power. Usually in the exam, it's usually dealing with power. But I mean, it's the same formula. By the way, you want it to be 100%. This is what you want. Will this ever happen?
No.
Not really. It's always less than 100. Can you just note this formula and also this statement? Oh, does anyone know the name of this letter? It's a Greek letter.
Micro.
Nice try, but no dice. Not micro. Not alpha. Not beta. Not gamma. Not delta. Not epsilon. Not pi.
N.
N is not a Greek letter. Sorry to tell you this. That's an English letter. Okay. Any other letters you know?
Epsilon.
Not epsilon. Not zeta. Not theta. Not phi. It is. Anyone know? No, no one knows.
Nano.
It is nano, not nano. Nano's not a Greek letter. It is eta. 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 Yeah.
Maybe teach us ABC of Greek sometime.
Maybe I should. I keep thinking maybe I should do ESCP lesson on it. Yeah. Cause it's, no, but maybe I should make a lesson for you. You can learn alpha, beta, gamma, delta, epsilon, iota. Yeah. It'll be good to know these letters for college, for university, because you'll use this in university more. Sigma, that's the other one. Okay, continue. You got this, yeah? Right. Let me see. Oops. Wait, what happened? I'm sorry. Down, come on. Right, we have 2 questions to do. Okay, so can you write this one down, please? It takes him, I should say it takes him 2 seconds, not his. Write this down, please. Just part 1. Just part 1. Yeah? Okay, so the first one, the power. So what is the formula for power? It's the work divided by the time. So if the boy lifts this book up, what work has he done? He's given the book potential energy. What's the formula for potential energy? mgh. Okay, so let's put in the numbers. And what's the m? Did you write it down?
Yeah.
What is it? 2. The g, 9.81. The h, what's the h? 1.1. And the time? 2, was it?
Yeah, 2.
So you get 10.8 joules per second, or you can write it as 10.8 watts. Yeah? Now just be very clear here. Does this have kinetic energy?
No.
No. Does it have potential energy? No. Does this have kinetic energy? Well, if he puts the box and he puts it and it's not moving
No.
at the top, no. Does it have potential energy? Yeah. Now these are not equal, but I said they should be equal.
Yeah.
So why are they not equal? Not this, no?
Conservation
Yeah, why?
to other
Just like heat or
No, 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 no. Why are these different? Well, the reason it's different is because the man gave it the energy. So you need to look at the man. Yeah, so if we look at the picture like this, man, belly, food, it's a man. And here's the box, and here it is at the end, and here's the man at the end. Belly, food. So if you look at it like this has no kinetic, it has no potential, but here there's energy in him. So at the beginning you have this. Then at the end, no kinetic, potential, and now no energy, no food. So you have, now it's balanced. So this is food, and this is potential energy. So this is how much work the man has done. It's how much energy the food. It's like the energy came from the food and became potential energy in the box. You get the idea? Yeah. So that's what I mean by part 2. He got this energy from his breakfast. However, half the energy is wasted as heat. What is his power now? So let's calculate the power of the man. And remember, I said the man, his efficiency is only 50%. Okay? So, 50% equals power out over power in times 100%. So you get a half equals power out over power in. Now, what is the power out? That's the work he did. That should be 10.8. Power in. How much power he did. Yeah. So this is how much power the man had, but he wasted half of it as heat. Yeah? That's the answer. Now when you look at food, it says how much energy is in the food.
The calories in.
Yeah, so if I look, give me your drink. If you look here, see here energy. Do you see that, Amanda? See here energy, and you see here it's kilojoules, kJ. So that's 16. That's 16 kilojoules for 250 milliliters. So if you drink a quarter, you get 16 kilojoules. 16,000 joules for a quarter of this. Yes? Any other food we can check? No. So it says on this how much energy is in it. Okay.
How about your coffee?
Coffee. Don't know. See, I don't think it's that high because it's just a liquid. You know, it's things like butter, chocolate. Well, not chocolate. Fatty food has lots of energy in it, but like coffee is mostly water, so there's not going to be too much energy in this.
Is there energy in water?
No, no. There's no energy in water unless there's impurities in it. So there's 0 joules of energy in it. Yeah. Okay, can we do the next one? Okay, can we write this one down? Last example.
No.
What do you mean no?
I
Last example,
I want to.
and then afterwards we'll all go back to Grace's home and meet her mother.
Yeah.
Yeah.
No.
No?
Why?
Why? We want to see her.
No.
We want to see if you look like her.
Yeah, I'm a big picture.
Yeah?
No, I will never give you the picture.
Yeah. Because maybe I'll see her in town. I say, oh, hello, Grace's mother.
Yeah. And no.
Yeah.
Never.
Never.
This happen.
Never.
I'll show your picture. If you see this guy.
Oh yeah, if you see this guy, stay away from him. He's a liar and a thief. Yes.
By the way, good idea.
Good idea, yeah. Yeah. Be careful, he will rob you. Yeah.
No. This is normal.
Okay, fine. Not real life.
Ah.
Yeah. Yeah. Okie dokie. Continue? No. Ready?
No.
Everybody wants to go home.
What?
It's 7.
I still got 4 minutes. Plenty of time.
Done.
Yes.
Yeah.
Okay. So let's start here. What's the mass of the car? 1200. Do we know the speed at the start?
Yes.
0, is it?
Oh yeah, 0, correct.
And the speed at the end?
100.
Amanda! Amanda! Right.
Don't drink or drive.
Yeah, don't drink or drive, yeah. Right. What else do we know? Do we know about the story? Do we know the time?
10 seconds.
Right, so we know the time is 10 seconds. And what do I want? The power.
Yes. The power of the engine.
Power.
Check it's kilometer per second or
Oh wait, was it?
Power.
Oh sorry, it's 100
Power, yeah.
kilometers per hour. We need to change that into meters per second. So that is 100 times 1000 divided by 3600 seconds, and we get here 27.78 meters per second. Okay, so what's the formula for power? Work divided by time. But what type of work was done? Kinetic. So that's a half mv squared over t. So you get power is a half times m times v squared divided by 10. So I got 46.3 kilowatts. That's part A. Part B.
Kinetic.
Mhm.
Kinetic
Kinetic, yes.
energy
No,
Only has speed.
Speed.
Yeah.
And potential energy.
Potential energy is only for height. No height here. On the ground. Yes? Okay, part B is if it was 40% efficient. So, in this example here, the power of the engine matches the power output of the car. But if it's only 40% efficient,
40%.
which will be bigger, the engine power or the output power?
The output power.
No, the engine will be
Engine power
bigger,
bigger.
because then 60% is wasted as heat. You still want the output to be this,
Oh.
okay? So you have now,
In the first question it was 100%.
yeah, so there was no need to make a difference. But in the second part, it's now only 40% efficient, so the engine needs to be more powerful to do the same job.
Although so it doesn't go faster or anything.
No, 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 I'm just saying if the engine was 40% efficient, you would need a bigger engine now to do the same job.
Mm-hmm.
So how big would you need? Well, it would calculate it, this is output, isn't it? Yeah.
It's 100%.
46,300. And then here is what we want.
Okay, what is it 46,000?
So that was the output power.
Okay.
Yeah. Okay. So here, the engine must now be bigger. If you want to do the same job, you need to have an engine that can do 115.8 kilowatts. You need a bigger engine.
In this conversation,
Yeah.
equation involving percentage, we can cut down the percentage by percentage.
Those two percentage signs can cancel. Yeah. Question, Grace?
No.
Are you sure?
Yes.
Really?
Yes.
You understand?
Yes.
So you can do the homework?
Maybe.
I'll show you the homework now. I know. Yeah? Got it?
No.
Got it? Yes?
Maybe.
Wait, we still have 1 minute. Anything else I need to say? No. You're all in tomorrow for the university day. I might see you there. Yeah. Do you know where to go tomorrow?
No.
No.
Check your email, so. Alright.